Public discussion about German military technology are usually dominated by a small number of highly visible combat platforms. Main battle tanks, infantry fighting vehicles, and self-propelled artillery systems tend to shape the public image of the Bundeswehr and Germany's defense industry. The Leopard 2 in particular has become a symbol of German military engineering and is often treated as the primary indicator of combat capability. While these platforms are important, they represent only a fraction of what determines real military effectiveness in modern conflict. Contemporary warfare is defined less by individual weapons and more by whether a force can function continuously under degraded conditions. Modern battlefields are characterized by destroyed infrastructure, persistent surveillance, electronic warfare, precision strikes, and sustained attrition. Roads are damaged or cratered, bridges are rendered unusable, terrain becomes impassable, and supply chains are constantly under pressure. Under these conditions, combat platforms alone are insufficient. What matters are the enabling systems that allow those platforms to move, be repaired, remain concealed, detect threats, and be sustained over time. Germany has invested heavily in these enabling technologies. Many of them operate in the background and receive little public attention, yet they form the technical backbone that allows combat units to operate in real-world conditions. Understanding these systems is essential to understanding how modern armies actually fight. One of the most critical and least discussed areas is heavy ground mobility. Modern armored vehicles place extreme demands on terrain and infrastructure. A Leopard 2A7 or 2A8 main battle tank weighs approximately 63 to 68 tons, depending on armor configuration and protection packages. The PZH-2000 self-propelled howitzer weighs more than 55 tons. Armored recovery vehicles, bridge layers, fuel tankers, and logistic trucks regularly operate at gross vehicle weights between 40 and 50 tons. Civilian roads and bridges are not designed to support repeated movement of such loads, especially under combat stress. In wartime, infrastructure is not merely inadequate, it is deliberately targeted. Bridges are destroyed to restrict maneuver. Roads are cratered by artillery and airstrikes. In rural regions, soil composition combined with seasonal weather rapidly turns open terrain into deep mud. Once heavy vehicles lose mobility, they become predictable and highly vulnerable to artillery, loitering munitions, and drone-guided strikes. Immobilization frequently leads to loss, even if the vehicle itself remains undamaged. Germany addresses this challenge through deployable trackway and mobile ground protection systems, engineered specifically for military loads. These systems consist of interconnected panels manufactured from high-strength aluminum alloys or reinforced composite materials optimized for load distribution, durability, and repeated use. Panel geometry and internal reinforcement are designed to support axle loads significantly higher than those imposed by modern main battle tanks, allowing tracked and wheeled vehicles exceeding 80 tons to cross safely. The technical principle behind these systems is ground pressure reduction. By increasing the contact area between vehicle and ground, pressure is reduced to levels comparable to civilian heavy construction equipment. This prevents vehicles from sinking into soft soil and reduces damage to underlying terrain. Surface treatments provide high friction coefficients to maintain traction in mud, snow, rain, or dust. Mechanical locking mechanisms prevent lateral displacement under dynamic loads, while structural reinforcement resists permanent deformation under repeated tracked vehicle passes. Deployment systems mounted on heavy military trucks allow continuous laying of trackway at operationally relevant speeds. Dozens of meters of roadway can be deployed within minutes, restoring mobility far faster than conventional field engineering solutions. From a tactical perspective, this enables armored formations to bypass destroyed infrastructure, operate away from predictable road networks, and reduce exposure to surveillance and indirect fire. In modern conflicts, immobilization has accounted for a significant proportion of armored vehicle losses, which is why Germany treats heavy mobility as a core combat capability rather than a secondary logistical function. Mobility alone, however, does not prevent attrition. Damaged vehicles must be recovered quickly to preserve combat power. Modern armored vehicles are designed with survivability, redundancy, and structural integrity in mind. Many vehicles remain repairable after sustaining damage from mines, artillery fragments, or anti-armor weapons. Without dedicated recovery capability, however, these vehicles are often abandoned, destroyed by their crews to prevent capture, or left in place to be targeted again. Each abandoned vehicle represents a loss of combat power and a significant industrial investment. Germany employs the Wisent II Armored Engineering and Recovery Vehicle to address this requirement. Based on the Leopard 2 chassis, Wisent II combines comparable mobility with heavy armor protection and specialized recovery equipment designed for forward area operations. This ensures that recovery capability remains available wherever armored units are deployed. The vehicle is equipped with a primary winch rated at over 70 tons of pulling force, sufficient to recover disabled main battle tanks under adverse terrain conditions. Auxiliary winches allow complex multi-angle recovery operations and vehicle stabilization. A heavy-duty crane provides the lifting capacity required for complete power pack replacement and major component removal under field conditions. A hydraulically actuated dozer blade enables obstacle clearance, route preparation, and limited earth-moving tasks during combat operations. Wisent II shares drivetrain, suspension, and powertrain characteristics with Leopard 2 variants, ensuring it can operate alongside armored units without becoming a mobility constraint. Its armor protects crews against small arms fire, artillery fragments, and battlefield debris, allowing recovery operations under threat. From an economic and operational perspective, recovery capability is decisive. A modern main battle tank represents an investment exceeding 10 million euros, excluding training and logistics. Recovering even a limited number of damaged vehicles significantly reduces long-term attrition and preserves operational momentum. Beyond physical systems, modern warfare is increasingly shaped by sensing and counter-sensing capabilities. Artillery remains one of the primary sources of battlefield casualties, but it is inherently vulnerable because firing reveals position. Effective counter-battery warfare depends on detecting, locating, and responding faster than the opposing force can relocate. Germany's Cobra artillery locating radar is designed specifically for this mission. Cobra detects incoming artillery shells, rockets, and mortar rounds by tracking their ballistic trajectories using advanced radar signal processing. By analyzing trajectory data, the system calculates the point of origin within seconds, typically with accuracy measured in tens of meters. Cobra can track multiple projectiles simultaneously, classify weapon types, and operate continuously under high-intensity fire conditions. Detection ranges exceed the effective firing distance of many conventional artillery systems. Once a firing location is identified, targeting data is transmitted directly into command and control networks, enabling rapid counter-battery fire, drone tasking, or precision strike allocation. Operationally, this forces enemy artillery units to limit firing duration and relocate frequently. Detection dominance must be balanced by measures to reduce detectability. Modern battlefields are monitored by persistent intelligence, surveillance, and reconnaissance systems operating across visual, infrared, and radar spectrums. Germany has invested heavily in multispectral camouflage systems designed to reduce signatures across these domains simultaneously. These systems employ layered materials that manage thermal emission, distort radar reflections, and reduce visual contrast with the surrounding environment. The objective is not invisibility, but delayed detection and reduced classification confidence. Lower thermal contrast delays infrared tracking. Distorted radar returns complicate automated tracking algorithms. Reduced visual contrast improves concealment during daylight operations. In an environment dominated by precision-guided munitions and drone-assisted targeting, even modest reductions in detectability can significantly increase survivability. German multispectral camouflage solutions are applied not only to combat vehicles, but also to command posts, air defense systems, recovery assets, and logistics hubs, where signature reduction directly affects force endurance. Situational awareness is further enhanced through reconnaissance platforms. The Fennec reconnaissance vehicle is optimized for long-duration observation without direct engagement. It is equipped with extendable sensor masts carrying high-resolution electro-optical sensors, thermal imagers, laser rangefinders, and secure digital communications. These sensors allow detection and identification of targets at several kilometers, while the vehicle remains concealed. Fennec's acoustic, thermal, and visual signatures are minimized to reduce detection risk. Sensors can be deployed while the vehicle remains behind terrain or vegetation. Collected data is transmitted in real time to command networks, supporting operational planning and force allocation. In modern warfare, timely and accurate information often determine outcomes before direct combat occurs. Sustained operations ultimately depend on logistics. No military force operates without fuel, ammunition, spare parts, and maintenance support. Germany's military logistics systems emphasize reliability, modularity, and interoperability with NATO standards. Heavy transport vehicles, fuel tankers, recovery platforms, and supply trucks are engineered for continuous operation in degraded environments. Design priorities include field repair capability, standardized components, and long service life rather than peak performance. When these systems are considered together, a coherent technical philosophy emerges. Germany focuses not only on weapons, but on the infrastructure required to sustain modern warfare. Mobility, recovery, sensing, signature management, reconnaissance, maintainability, and logistics form an integrated system designed to maintain operational effectiveness over time. These technologies rarely receive public attention, yet they determine whether advanced combat platforms can be deployed, supported, and sustained under real combat conditions. For this reason, some of the most important German military technologies are also the least known. What are your thoughts on these German military technologies? Let us know in the comments below. If you enjoyed this video, don't forget to give us a like and subscribe to our channel to get the latest videos straight to your notifications.